I request Dr. Sumya Fatima to please continue the session.
Okay, thank you so much for inviting. And let me start sharing my screen first. Okay, so hello everyone. This is Dr. Sumaya Fatma. I am the founder of the Scholars Guild Research Mentorship Program. We deal with different kind of study designs, cross-sectional cohort, clinical audit, and now we are in the CDC vendor analysis, and now we are starting the systematic review and meta-analysis next month. So I was really excited that I was invited for this session on SPSS analysis session. That's really nice because let me tell you guys a little bit. One thing that's really important is that when you will start, inshallah, after your MBBS, when you will start applying for different things, then some of you guys might even go for different research assistant positions, or some of you are applying for USMLE or PLAB or places like that. It's very easy if you have good research skills to go to US or even UK or any place in the foreign, and you can apply for any research position. There is comparatively less competition in that field, okay? And one thing they are expecting from you guys is what they are expecting is that you should have a good grasp of different study designs, okay? And the first thing that is that you should have many skills as you can, okay? So a person who says I'm a researcher, okay? If you are writing in your CV that I am a researcher, the first thing that you have to know is that you have to let them know is that you know SPSS. Okay, SPSS is like the most basic thing for a person who is saying I am a researcher. Okay. And then there are R program, Joint Point, other softwares that you can use, Python, and then there are more of the things. But SPS is just like the baseline. If any of you have around 10 publications, but he has never ever done SPSS and he has never worked on SPSS, he can never say that I am a researcher, okay? Because that would just be, that's not possible if you are not having knowledge of SPSS and you are saying that I know research, okay? And SPSS is just like the basics of it. So I was happy because to conduct this session that is on analysis using SPSS, what I would be going through is I will make you guys go through the basic steps, okay? I will show you guys the interface of SPSS. When you download SPSS, how does it look like, how you can use it, and it's very, very easy, okay? SPSS is just like the easiest software that you can ever use. Even if you write in ChatGPT or Gemini, which one is the easiest statistical software for data analysis, you will find SPS at the top. Okay. So, whenever I am mentoring my students, some of them are like only one student volunteer that I will do the analysis and all that stuff. And I always, always encourage them that I want all of you guys to go and open SPSS and just go through it. Okay, just go through it once so that you know that how much easy it is. Okay, so these are the first steps. First, what you do is after data collection, you will export your data into SPSS. We will also be doing the hands-on, so you guys don't need to worry about that. Okay, it won't be just a theoretical session. We will be doing a hands-on side by side. Okay, so the first thing after data collection, that is you will export your data to SPSS. Then you will identify your data. You will be making the graphs and the tables, and then we will conduct some tests. Okay. I will be dealing with the basic test, the chi-square test, and the t-test, and then the regression and ANOVA. For that, I will share with you guys a recording that you can watch if any one of you is interested in a detailed analysis. Okay. So let me start. Okay. So these are some of the basic things that you should know before starting the data analysis. There are two types of data, numerical data and the categorical data. Okay. What I find myself easy to say is the words quantitative and qualitative. Okay. That's easier to understand. And why is this necessary? It is necessary because this will help you decide which test to apply. Okay. So if your data is all quantitative, like you are dealing with just numbers, okay? So you will be conducting different tests. Yes, I will share with you guys also the link to download SPSS. I will share with you the data set. I will share with you the slides. Right now, what I want you guys is to just focus so that after the session, you are just in tune with this thing that it is easy to do SPSS, okay? It will take you guys just like around 15 to 20 minutes to run all the things that we will be covering in this session, okay? So one thing you just have to recognize is whether my data is qualitative or quantitative, okay? So quantitative is from the word quantity, numbers, numerical data, okay? Like, for example, I say, I'm experiencing pain at the score of 5. So that is, I can say my data is quantitative. But if I am saying I'm experiencing severe pain, so that means my data is qualitative. Okay. So when I'm using the words, that is quality. And when I'm using the numbers, that is quantity. You don't need to go into discrete, continuous, nominal, ordinal. That's not necessary for the moment. You just need to know, is it quantity or is it quality? Okay. Second thing, what you need to know is whether the data is paired and unpaired. For the paired, that means before and after. Okay. For example, some of you guys might be doing clinical audits or might be part of clinical audits and stuff like that. Or even if for this session, if I conduct a research or if I conduct a questionnaire and I collect responses of your knowledge regarding SPSS before the session, and then I collect responses after the session, then I would be going for the test that deal with paired data. Okay, that is pairing before and after treatment. For example, there was one of our research that was on hemodialysis. Okay, yes, I am telling you guys everything. Okay. So there was a research on hemodialysis. Okay, that was about those patients who, when I was doing my nephrology rotation, and we conducted a study on the renal function tests of those people before dialysis and then after dialysis. Okay, so that was about the before and after paired thing. Okay, and even if there is some of you guys would be doing like I gave the example of clinical audit. For example, you guys do what are the levels of cleanliness in a unit, in a specific unit before and then after the audit, what are the levels? So it's just like that. That's the pairing. Okay, before and after, you two data that are paired by some kind of intervention or treatment. And what is unpaired? Unpaired is all the data, all types of cross-sectional event studies that we do. What is the prevalence of hypertension? What is the prevalence of this and that? So that is all unpaired data. Parametric and non-parametric, that's a little bit of a detailed discussion. We will not be going into that. If we will have time at the end, we will be dealing with that. Otherwise, it's not necessary for the really basic stuff. Okay, so what we have covered so far, we have seen the qualitative data and the quantitative data and the paired and the unpaired. You have to just remember that for now. Okay, so let me open up my SPSS so I can show you guys some of the stuff. This is a version of SPSS version 27, and the most recent one that is available, that is the version 28. Okay, that's a little bit difficult to use. I don't like that personally, so I go for the version 27. And in the version 28, the features are a little bit they are all new features. So I mostly prefer to go with the version 27. Okay, but if you guys are comfortable with the version 28, you can also go for that. So when I first downloaded my SPSS, I saw this thing that these digits and these options were not available. Okay, so I thought maybe I have not downloaded the right version. So what I did is I uninstalled this whole SPSS and I downloaded it again. But actually the thing is that this is perfectly fine. There is no problem in it. Okay, this is the interface of SPSS. It's quite easy. Okay, it's not like a coding or programming software where you have to like write a specific code, or even Stata. Some of you guys might have used the Stata. It's a little bit difficult to use. You have to write codes and all that stuff. So SPSS is easier in this regard. Okay, there are just two views. one is a data view, okay, and then there is a variable view. So what we do here is, firstly, we will write our variables. Variables are the questions in your data set. Okay, let me open up a questionnaire. I guess one would be open here. Yes, let me open up this one. Okay, so for example, you guys can see this one. This is my questionnaire, okay, and I have around. Okay, this is my questionnaire, and I have around 97 responses. Okay, I'm opening up the responses sheet. Okay, so these are some of the questions that I asked in my oh, it's just giving an error. Okay, in my questionnaire, in my research, that was about what was the gender of the person, what was the age group, what was the site of foreign body, time since insertion, and all that stuff. Okay, so the first variable is gender. What I will do is here, I will write gender. Okay, that is my first variable. It has automatically created a variable now. Okay, so in here, in this variable category, you only have to fulfill this name, label, and the values. Okay, you're not concerned with the type, you're not concerned with the weight, the decimal, even the missing one, and all the rest of the stuff. Only things that you are concerned with is this name, label, and values. Okay, so in name, what is name? That is just a code for me to understand this variable, because when I will be working in this data view, this name will be showing here. Okay, if I write just Jen, it will show me gender as the word gen. Okay, this is just a code, because when of course there are many variables, around 20, 25, it becomes crowded. Okay, so this is just a simple code for me to understand that what variable this column will be showing. Okay, so if I rotate my cursor over this one, it is showing me that. Okay, it's showing me the name again. But this label is the full statement of the variable, like gender. Okay. Then let me show you guys another one. That is this one, the site of foreign body. Okay. So I copy it, I paste it here. I cannot put spaces in the name. So I will just write site, and in the label, I will write the whole thing, the site for a foreign body. This label is important when you will be making graphs and tables. SPSS will pick the whole name from this label. Okay, so you will be writing the full statement in this label section, but in the name, that is just a code for you to understand. Okay, so I have written the complete thing here, site of foreign body, and I have written the name, just the site here. And you can see that it is showing just site here. Okay. So these are just the codes for me to understand when I am working on this data set, and this variable labels are for making the tables and the graphs and all that thing. So for gender, we have male and female. Here I can even give them values. One means male and two is female. Okay, so now I can easily add this data here. One, two, even one. Okay. This becomes easier to write. Okay, instead of writing the whole male and the female, I can just write 1 and 2, and SPSS will be reading this data. Okay, so this is some of the stuff that you guys need to know while using the SPSS. You can add more variables here, and you can even add more values and all that stuff. Okay, this is the coding stuff. Let me show you guys some other options that we have in SPSS, and then we will be moving on to our new sheet. Okay, just leave it that for now. Okay, So for now, whenever we are conducting our mentorship program, and when we reach the analysis part, I mostly divide the things among my mentees and my students into 5 parts. Okay, so the first person, what he has to do is he has to copy all this data like this one. Okay, this whole column. He has to copy all this data here, and he has to do the coding. This I call the coding. Okay, so assigning values to them, and he has to do this coding and clearing of the sheet. Okay, that is for the first person. What the second person has to do is he has to run the descriptive statistics. What the third person has to do, he will run some of the tests like I square t test. Fourth person makes the table, and the fifth person makes the graphs. Okay, so it becomes easier, and every person is just putting around like 15 to 20 minutes on analysis. Okay, so let me open up another sheet, and we can do better on that one. Okay, so this is, do you want to proceed? Okay. Open the data set. Sorry. Okay, so this would be the data set that we'll be working on. I have already labeled them as 1 and 2, male and female. Okay, 1 is male and 2 is female. Same for the years of study. I'm really sorry. I don't know why it's okay. So fourth year is labeled as 4, 1, 2, and all the coding has been done. Okay, this is the numerical data. We don't need to code it. It's already in numbers. Same for this one and same for this one. But we have coded this one. 1 is square pane and 0 is no pane. Okay. So what this data set is about, because we will be conducting tests on it. So I just need you guys to know a little bit about it. This is on fibromyalgia. Okay. Fibromyalgia is the pain that you feel in your joints when you are stressed. So this was one of our research, and I took the data set from there to better explain you guys some of the stuff. Okay, so in this variable, you can see which one is the qualitative variable. The gender is the qualitative variable, and this one, back pain, also the year of MBBS. Okay, we have just covered two things, that our data can be qualitative and quantitative, and paired and unpaired. Okay, so we can spot in this data set, we have three variables that are qualitative and three variables are quantitative. Okay, so these variables, male, female, first year, second year, and back pain, severity, these are all qualitative variables. We would be applying the tests that are related to qualitative variables on them. And these three variables are quantitative. This is the this is the pain score. This is weight before exercise, and this is weight after exercise. So weight before and weight after, this is paired variable, and the pain scoring is an unpaired variable. Okay, so you have got all of this stuff here. We have qualitative data, quantitative data, paired, unpaired, paired data, and then we have the unpaired data also. Okay, so let's move on to our presentation again. Yes, let me just repeat the steps a little bit from the start. So what we have discussed so far, that we have discussed this thing that first we have to look at our data. Okay, first we will be looking at our data. Which one are the quantitative variables, which are the qualitative variables, which are the paired variables, and which are one are the unpaired variables. Okay, so first we have to just see that. Export the data from the Excel sheets to SPSS and then code them. When I started research, we had no idea that Google Forms could transport the data from the Google Sheets to SPSS. Okay, so what we used to do is, what we used to do is, we would one of us would repeat those variables, and the other person would do the data entry in SPSS. It would take us around like a day or two to just add the whole data in the Excel, in the SPSS sheet. So Google Forms is a very fast way to transfer the data from your questionnaire to the SPSS. Okay. So yes, that's the first thing. And then you will have to look at your data, identify the data, describe your data. Okay. Next thing we have to see is which test we will be applying. Okay, so for the person who is saying that please repeat whatever you guys have covered, we have covered. We have just started. We have just seen how the interface of SPSS and about the data, different types of data categories. Okay. Okay, so for the missing value also, that was left. Let me cross this one. Okay. Sometimes this happens that when you export your data from the Excel sheet to SPSS, imagine that these variables are missing. Okay. So, and it's a very hard thing to collect data already, okay? And you have collected around 200 responses, and you are like, I cannot do this thing that I exclude these responses because some of the data is missing. What you will do is for the missing variables, there is one thing that you have to do is if your data is quantitative, just like this one, there are numbers, you can replace these missing values with the mean of the data, okay? So what I will do is I will just select this and I will go here, transform, replace missing values. This is a weight. And I will say replace the missing values with the series mean. Okay. It has already assigned it a new name and it is saying I should replace it with word, replace it with the mean of the series, and I will press OK. Yes, replace it with the mean. And now you can see here that this data was missing, but now it has replaced it with the mean of the series. Okay. So now our data is proper. We can use this. Yes, I will show you guys again. So let me just delete this. Go for the one using the one that has now replaced the set. Because the one thing that is looking at your data that also includes making sure that no variable is missing, no variable is out of place. There should not be a thing that um, some of the variables are wrong or missing or anything like else like that. First, you have to clean your sheet, code it, transport it, and then you have to move towards the further analysis. Okay. How to transfer data into SPSS? Okay, so there are two ways. One way is if your SPSS is a licensed SPSS, you have bought it from somewhere and stuff like that, you can easily open it. You can open the Excel sheet, okay? That the Excel sheet that we copied it from here. Okay, you download it and open the Excel sheet. The other way is that you just copy these columns. For example, I just copy this column and I will paste this column here. And then I will add another column, and then later on I will name this as a gender after copying it, and then I will code it again, and then I will do the cleaning, and that is all the steps. Okay, so let me show you guys again how to replace the missing values. For the quantitative one, you just have to go here in the transform section, transform, replace missing values. Okay, this one. And then we have the weight, and then I will be replacing, it's saying it's already set to replace the missing values with the mean. Okay, so and I will press OK. I will cross this output window and now it has replaced it with the mean. Okay, there is no missing data now, but it has now double copied because we have just done it again. Okay, so let me just go back. Let me replace it again and then we can go for, oh my God, I don't know why this is happening. Okay, replace missing values and replace with the mean. Fine. Okay, now it has been replaced. I hope there are no extra rows. Okay, no. And for the quantitative variable, if some of the data is missing, okay, for example, you can imagine that people have not entered their gender. Okay, so the male females are missing here. What I will do is there are two ways to do this again. What some people do is that they replace it with the majority. Okay, for example, I run the chi-square test. I run the frequency table on it, analyze descriptive statistics, frequencies. Okay, and I say display frequency tables. Gender, I will put it here and then, sorry, and then I will press OK. Male, okay, so male are around 23% and female are around 58%. What some people do is that they replace the missing ones with the majority ones. Okay, just like I will replace it with two female and I will replace them all with the two. Okay. But what happens in this case is that there is a chance of a bias. Okay, so some people can say that you are making the results biased by replacing it with the majority. Okay, some people more do is that they replace it with the hypothesis that they want. What they want is the people more female should be experiencing swear pain. So in front of the swear pain, I choose female, and in front of no pain, I go for males. So this is some kind of way you can say that I am making the data biased. What I do is, and what is like the main acceptable thing is to replace the missing qualitative variables with with the one that is lesser in number. Okay, so that your data is not towards a biased one. Yes, it is necessary to fill the missing values, otherwise your data would be empty data. Okay, so it would not be acceptable if you have so many of the missing variables. So in this case, we had this whole missing, and then I run the frequency tables. I went into analyze, I went into descriptive statistics, frequencies. I just said display frequency table, and I pressed OK. And it showed me that males are less. Okay, males are less in percentage, they are just 23.5%, and females are 58.5%. So I will replace all these missing values with males. Okay, 1, 1, 1, 1, 1, 1, 1, 1, 1. And now I can say I am not biasing the data because I have added a value that is already in minority. Okay, so that's the way to replace the qualitative variables. Quantitative one you have to replace with the mean, and for the qualitative variables you have to replace it with the. When do we replace the missing variable with 999? That's up to you guys. I never use that thing. Okay. Some people do is they add zeros and all that stuff, but the ideal way is to replace it with the mean for the quantitative, and for the qualitative, it's best to replace it with the majority or the minority variable. No, it's not biasness because what are you biasing towards? Okay, mostly the bias is towards a conclusion that we want to make. So we are supporting that more males are experiencing pain and all that stuff. More females are experiencing swear pain, and I'm replacing them with the females, and I am biasing towards a major thing. So it's just like that. Okay. Yes, one thing also you can do is to delete the data that's missing. But if you are already doing a research where data collection is hard, it's better to save your responses. Yes, I will explain at the end. I just don't want it has been 30 minutes and we have just not covered anything at all. Mm-hmm. No, the whole data is not being replaced by mean. It's only those specific variables. It's only the missing variables that are being replaced with the mean. Okay, so guys, this is the important sheet that you all need to remember and even keep with yourself. I always keep this open whenever I'm doing an analysis. Okay, I have done around like around you can say personal, my publications are around 30, and with my mentees, we have done around more than 100 projects. But I always, whenever I am doing analysis, I open the statistical sheet, this one, which test to use, and then I write on a paper. I keep a paper with me, and then I write, okay, so this variable is qualitative and this one is quantitative. I can do a test, this test on this. Okay, so it's not something that you might guys might be thinking that the person who is experienced in analysis, they just look at the sheet and then they get an idea, okay, I am going to apply this and this on this. They also need some kind of processing beforehand to realize which test or which statistical test they have to go for. Okay. Yes, of course, I will be giving an example. Okay, guys, wait a minute. You guys have to keep up your questions. Okay, you can drop in the chat box and we will be dealing them at the end, because whenever I change, I read your message, it just makes the screen disappear. Okay, so this sheet is very important. What it is about, if I am able to convey this to you guys, it would be enough for the whole session. So there are two things. First one is the predictor variable, that is categorical, and the quantitative. Okay, so they have used the words categorical and quantitative variables. Okay, what we were discussing, we were calling the categorical variables as the qualitative variables. So if I use the word qualitative, that means categorical, but I will stick to categorical for now. So qualitative means categorical, or you can even remember the words, and quantitative means the numbers, the quantity. So if your predictor variable is a categorical variable, for example, your independent variable is a categorical variable, and your outcome variable is also a categorical variable, you will go for a statistical test. Okay, that is a chi-square test. For example, in this one, if I want to see the relationship between gender and back pain, okay, that is gender influencing back pain or not, I will go for a chi-square test. Okay, I will show you guys how to run it. First, we will just see the different types of tests. I just want to know the relationship between gender and back pain. Are females having more back pain? Are males having more back pain, or stuff like that? Both are categorical. Both are, there is no number among them. So I will use a chi-square test. Chi-square test is just the most basic test that one can ever use. Okay. And whenever you do a research, you always have to apply the chi-square test. If you apply correlation, regression, and ANOVA, your chances of publication automatically increase a lot. Okay. But if you're not applying chi-square test, your article is almost rejected at the start. Okay. Because all journals are expecting that you would have applied chi-square test. This is like the most basic test that you can apply. Okay. And the more, of course, as I told you guys, if you are applying regression, if you are applying ANOVA, that's like a bonus thing. Okay, if in your results, in your abstract, it is written regression was applied, ANOVA test was done, automatically your article is more chances of it getting published. And but if you have not even applied chi-square test, your article is almost rejected at the start even. Okay, so these are some of the mistakes that people do when writing the abstract even. So if I want to just see the relationship between sex and the back pain, I will just go for the chi-square test. Both are qualitative, both are categorical, and I will apply this test. So next one is, if your predictor variable, okay, is categorical, and your next another variable, that is a dependent variable, outcome variable, is quantitative, you can either apply t-test or you can apply ANOVA. Okay, we are not going on the regression side for now, we are just discussing this side. First, I have discussed the chi-square test. Now we are moving to the t-test and ANOVA. Let me explain it to you guys with example. Okay. Next thing is, I want to see this pain, that is quantitative. Okay, so this is the categorical variable. I want to see, is gender, how much is the pain scores affected by gender. Okay, so this is the outcome variable and this is the categorical variable. What I will be doing is, I will be applying t-test here, because this is numbers and this is categorical. So what I can do is, I can apply the t-test. Why t-test and why not ANOVA? Because there are just two groups here, male and female. And if I want to see what are the pain scores in different years of MBBS, and because there are more than two, first year, second year, third year, fourth year, I cannot apply t-test here. I will have to go for ANOVA. Okay, let me repeat it again. These are the independent variables. Gender and year of MBBS, they are not affected by anything. But pain is the outcome variable, and it is being affected by whether you are male or whether you are female. And it's also affected by which year of MBBS are you studying in. Okay. So if your groups are two, like male and female, you will go for the t-test. And if the groups are more than two, you will go for ANOVA. That's it about the t-test and ANOVA, nothing more. First, we discussed the chi-square test. That was when both are words. Okay, that the chi-square test is when both the variables are categorical. And the second one is when one of the variable is qualitative and the other one is a quantitative variable. Yes. Now, this question that you have asked, is there a significant difference in the mean values? That we will be checking from the t-test. So let me apply the chi-square test first, and then we will apply the t-test. Let me apply a chi-square test between the gender and the back pain. Analyze. Okay, so for those who are messaging to explain it in Urdu, okay, for the test I can say it. chi-square टेस्ट आप लोग तब अप्लाई करते हैं जब दोनों जो हैं कैटेगोरिकल हैं, ठीक है, जैसे कि मेल एंड फीमेल दे आर बोथ इन वर्ड्स, तो इनके बीच में हम लोग chi-square टेस्ट अप्लाई करेंगे। जब हम लोग ये चीज़ देखना चाह रहे हैं कि जो पेन के स्कोर्स हैं वो मेल फीमेल में दो ग्रुप्स में किस तरह डिफरेंस कर रहे हैं, तब हम लोग टी टेस्ट अप्लाई करेंगे। और जब हम लोग ये देखना चाह रहे हैं कि कोई क्वांटिटेटिव वेरिएबल जो नंबर्स में है वो ज़्यादा ग्रुप्स में किस तरह डिफरेंस हो रहा है, तो हम एनोवा लगाएंगे। ठीक है, सो लेट मी स्टार्ट अप्लाइंग द chi square टेस्ट। आई विल गो इन एनालाइज, डिस्क्रिप्टिव स्टैट्स, क्रॉस टैब्स। ओके, आई विल प्रेस द क्रॉस टैब्स बटन। Okay, so in the rows, I will add gender, and in the columns, I will add the back pain. I will go in the statistics, chi-square. Then I will press continue, and I will press OK. Once again, let me show you guys the steps again. Analyze, descriptive stats, cross tabs. Gender in one box and the other one in the second one. Statistics, chi-square, continue, OK. So now what is it's showing me? It's showing me that 18 females were having no pain and 12 females were having severe pain. Males had low pain scores. Okay. Because here male and female are not equal, what we have to do is we have to calculate the percentages when we will be reporting the data. Okay. So I will have to report the percentages like this. 18/30. 18 divided by 30. 0.6. Okay, to multiply by 100. 60% of the females had no pain, 40% of the females had severe pain. Okay, what about the males? 12 divided by 21 into 100. 57% of the males had no pain and 42% males had severe pain. Okay. So, although from this table it looked like that males are having less pain, but the stats are showing something else. Okay. So, let me move down. This is the table that is showing us the p-value, okay, or the value of significance. If it is less than 0.05, then our data is significant. But here it is showing it says 0.8, so the value is not significant. Okay. Like zero cells, because also one thing that is important is because we are dealing with just 50 responses, so our values are not coming as significant. Okay, so it's 0.8 and 0.83. How I will be writing this in my results? I will write this as, okay, yes, I will be repeating the calculation. No, you will not be making a graph for the chi-square test. Okay, so this is how you will write it. Okay, results around. Let me copy these tables here. Okay, so first we will be writing about the males. 12 out of 21. 12 divided by 21. 57%. Okay, around 57% males, bracket, and is equal to 12 over 21. Males experienced no pain and no, it's not out of 32. It's this is these values that are showing here. That is for the back pain, none values, and for the square one, this is for the gender. Okay, it's like this. You have to read it in this way. Total males are 21. Total females are 30. Around 57% male experienced no pain and 43% males experienced severe pain. Okay, same for female. We have to similarly, we will write anything else. But at the end, we will mention there is no statistical significance. और फिर आगे हम लोग mention कर देंगे p value is equal to 0.838. When the data is more than 100, okay, the p-value will be showing here and it should be less than 0.05. Okay, exact significance would be showing on the exact significance side. Now here it is 0.8, so it is not statistically significant data. Why it's not coming statistically significant? One thing is because we are using just a sample data. Another thing is because our sample size is less. There was a study that was published in New England Journal of Medicine, and the person, New England Journal of Medicine, you guys might know, it's a W category journal. Okay, it's the highest category of journals people even aspire to get their articles published at. Okay, after Lancet and all that stuff. So that person, he published a research on just two apples. Okay, and he applied all the tests and all his tests were negative, were not statistically significant. Why? Because he was just using two apples. Because but the study was conducted in such a nice way and it was like so proper study and it was a proper experimental study that it got published in the New England Journal of Medicine. So it is not about that your data is coming out not significant. Yes, you should try your max that your data should be statistically significant. And if you are having a lot of variables, here I am having just a few variables. I am having just 6 variables. But if you are having a lot of variables and you can run many tests, it's better to report only the statistical significant data. Okay. But if you are not having any variables and you are having just a few variables and the data is not coming significant, you cannot do this thing that you try to make it significant or you just leave your research. Okay. You can go for reporting the not statistically significant data and try to get it published. But yes, there is a problem that you should have more all the variables that are showing a statistically significant data. Many journals do not accept researches that have um, that do not have significant results. Okay, so for that thing, if your data is not coming significant, one thing that you can do is try to collect more data, and sometimes that makes your data significant. Okay, so that was about the t-test. That was about the chi-square. Okay, we went into analyze, descriptive statistics, crosstabs, and then then I showed you guys how to apply the chi-square test. That's the basic test. You have to apply it on all the variables you can. Okay, so the next variable also we can apply it just to make you guys understand more. Because year of MBBS and back pain, they are both categorical variables. I can apply chi-square test between them. Descriptive stats, sorry, analyze, descriptive statistics, crosstabs, year of MBBS, back pain, chi-square test, continue. Let me close this one. Okay. Okay, so for the year of MBBS, our data has come out to be significant. Okay, you can see here the Pearson chi-square value asymptomatic significance is less than 0.05. So there is a statistically significant difference in the pain levels of all these years of study. Okay, let me copy it here. No, you cannot use ANOVA here because both of the variables are categorical. Okay, I will be showing you guys when to use ANOVA. Let me show you how we will report this data now. Firstly, you will write there is a statistical significant difference between pain scores, between pain levels among different years of study. Okay, you will just use this statement and then you will write the p-value that is 0.002. This A value that is showing, mostly we call it the P value, but to differentiate between this P and this P, we use the word A, okay? That means that where we are using the standard as 0.05, our P value is 0.002. So that means that it is significant, okay? We are using this thing again and again. If it is less than 0.05, your data is significant. So this A is that standard. We have to mention this, okay, that we are using this standard. Some people use 0.01, and that is for other types of researches. That's a little bit of theoretical thing. But we have written here that our p-value is 0.002, where we are considering A as 0.005. Okay, so there is a statistically significant difference between pain levels, but your statement does not end here. Once again, as we did for the males and females, you have to calculate the percentages and you have to write them, that there were how many students of first year were experiencing pain and how many years of MBBS were experiencing pain and all that stuff. Okay, why this is important? Because in this statement you are just saying that there is a relation. So the person who is reading your article, he wants to ask what is the relation. You have to explain that relation, and you will explain that relation from this table. Now it has become very easy to write the results. Sometime what even I do is I just go in. You can go in Chat GPT or Gemini, and you can just put your. I can just copy paste the table here, and I will say help me write this table in paragraph form. It will help you write the whole thing. Okay, in the first year 15 students were surveyed with having no pain, so it has become very comparatively very easy to write your results. Okay, you don't need to calculate everything. You can even ask him, help me write the percentages, and it will give you the percentages also. Okay, so this we can say. Okay, so just I will be deleting this thing. I will be moving on to the next one, that is the t-tests. Okay, so the t-test and ANOVA, they are applied when one is categorical, okay, that is in words, okay. Earlier I was using the word qualitative, I just shifted to categorical because of that chart. But If it is in word, that is qualitative, and if it is in number, that's quantitative. You can use t-test and ANOVA only when one is variable is in numbers and the other one is in when the other variable is in words. Okay, so that this one is in words, that is male, female, and this one also, and but the pain scores are in numbers. Okay, so if I want to see the difference in mean values of pain among male and female, I will use a t-test. Okay, why I'm not using ANOVA? Because the groups are two. Male and female are just two groups. If there are more than two groups, we will use ANOVA. So now I will be using t-test. I will go in analyze, compare means. Earlier I was going to the descriptive statistics. Now I will be going to the compare mean independent sample t-test. I will use this one. I will add the pain here, pain score here, and gender here. It is asking me define the groups that you have. So I was naming males as 1 and female as 2, and I will press continue. You don't have to change any other thing. You will just press OK. Okay, so it is showing that the mean value of pain in males is 18 and mean value of pain in females is 10. This is just a comparison of mean. This table is showing you the t-test, okay, the value of t-tests. You will not go for looking at this one, Levine's test. You will just see this one. That is a t-test for equality of means. And here you can see the significant value is less than 0.05, so our data is significant. How you will report this data? You will again write in this way. In this presentation, I have added the way to report the data. Let me just copy that. I have kept this presentation and I will be sharing it with you guys also. And whenever I'm doing an analysis, I just go here, I open up the test and I copy the reporting from here and I just put it in my Word document and just change the values here. An independent sample t-test was run with a confidence interval of 95%. It was found that the pain scores in males and females were significantly in males were significantly higher than females. And in front of males, you can add the score. That is 18, mean 18, and females mean was 10. Now you have to add the value of t-test. P-value is less than 0.001. It was less than 0.001. What is the t-test value? This one is the t-test value, that is 14.6, and this is the degree of freedom. Okay, I will explain it to you guys. I will add it here, 49 degree of freedom, and this is the 14.6. So this is how you will be reporting the t-test. Okay, an independent sample t-test was run with the confidence interval of 95%. Confidence interval means that you are 95% sure that this data is right. We always keep a margin of error of 5%. This is just some of the theoretical stuff. Okay, if I go in many detail, it would take up a lot of time. And it was found that the pain scores in males, and here you will write the mean of males from this table. Okay, 18.8 was significantly higher. Pain scores were significantly higher than females, mean 10.3. And in front of that, you will add the t values, okay? Statistics of t from this table. 0.001, that is the significance. This is the t-test value and this is the degree of freedom. Degree of freedom means how much the value can change, okay? You can also read it on again for the theoretical things if you want to. Okay, so if I'm just comparing the means, I'm saying that the pain scores of male was higher than females. You always have to run some kind of a statistical test, like a chi-square test is a statistical test, t-test, ANOVA, and regression. You cannot just say that the means are this and that, okay? Because if you are not applying a statistical test, you are not showing that your data is significant or not, okay? And you have to report the significance of the data. Next one is the ANOVA, and then we will just go, and after that we will try to wrap the things up. I will give you guys a summary also. Let me conduct the ANOVA test now. I will run into analyze, compare means, one-way ANOVA, pain values here, and year of MBBS in this one. And then I will press OK. Okay, so it is showing me this one, this values of ANOVA. Okay, ANOVA, it's saying that the differences between the different years of study is significant. Okay, that is 0.002. Yes, I will show you guys how to do run ANOVA. Let me just copy it here. Actually, ANOVA is a little difficult to run, and I'm just thinking, should I do it or should I not? So this is how you will report it. I will just copy it from here to this Word document. A one-way ANOVA was conducted to determine the effect of years of study on pain scores. The results show a significant effect 0.002, 0.020. F value is 3.61. Degree of freedom is 3. This you can get from this table. And let me show you guys again. Okay, one of you has asked how many tests of significance to apply for. Okay, so and the answer is that if you are able to run correlation, regression, and ANOVA, it is best to go for them. Okay. But if they are not applicable on your study, okay, so it's better to just apply one test, that is a chi-square test. Okay, but it is better if you can to apply ANOVA and chi-square test first, ANOVA and regression first, and if you are not able to do, and then you can go for the lesser one, that is the t test and the chi-square test. Okay. So here you can even see that I was not able to apply any other test. Between categorical variables, I had to apply chi-square test. To check the mean values of two groups, I had to apply t-test. And to check between the pain scores and year of MBBS, I had to apply ANOVA test. Okay. And when I will be comparing two quantitative, I will have to go for correlation and regression. So we will not be discussing correlation because it becomes a little difficult. ANOVA is the last thing. Let me run ANOVA test again. I will go into analyze, compare means, one-way ANOVA. Okay, here I have added pain, it's a quantitative variable, and here I have added years of MBBS, it's a categorical variable, and it is having more than two groups. Okay, male, female were just two, that's why I applied t-test there. But for the years of MBBS, I have to apply ANOVA test. Okay, I have added pain here, and in the factors, this one I have added the categorical variable, that is years of MBBS. In contrast, I will not change anything. In post hoc test, I will take the two keys test and I will press continue. Nothing more, I will change nothing else, okay? And I will press OK. How to know which to keep in the factor and which to keep in the table? In the table, you have to keep the dependent variable. Okay, that is the pain that is being affected by the years of MBBS, and in the factor, you have to keep the independent variable. That is the demographic variables. Okay. So this table is showing the values of ANOVA, and it is showing us that our result is significant. It is less than 0.05. It is significant. When your test comes out to be significant, you have to run the two keys test that we chose before. Okay, let me show you guys again. Analyze, compare means, one-way ANOVA. If my test was not significant, I would not have gone for this post hoc test. But my results are coming significant, so I have to go for this post hoc test. Okay. So I will press two keys test, just this one, and I will press continue. And I will press OK. My tests are significant. I have written about them here. Okay. That a one-way test was conducted. The results showed a significant effect. But now you have to conduct the Tukey's post hoc test. Post hoc test is done to further explain. Like we were explaining that table earlier कि males के पास इतनी pain है, females को इतनी pain है. The Tukey's test is also to explain further, okay, that what is making this test significant. So post hoc test was conducted, and we will see here in this post hoc table कि कौन सी value significant आ रही है. Let me just copy it and paste it here. Is this value significant? 0. Sorry. 0.981? No, it's not. Is this value significant? No. Is this value significant? Yes. I will highlight this one. This step is a little difficult, but if you guys can understand this, you will be understanding ANOVA, okay? So you will be left with just the regression, and you will have done like around 80% of SPSS. Okay. Next thing is this value significant? No, it's not. Is this value significant? No, it's not. Is this value significant? Yes, it is. It's less than 0.05. I will highlight it again. Is this value significant? No. It is this? No, no. Is this value significant? Yes. What about this one? Yes. So two values are significant, and in front of these two values, we have to see this value. Okay, this is the difference, the mean difference. If the mean difference is positive, we will report it. If it is not positive, even if the value is significant, we will not report it. So is this positive? No, it's not. So we will not be reporting this one. Is this positive? No, it's not. We will not be reporting this one. Is this positive? Yes, it is. Is this positive? Yes, it is. So how will we report these two tests? We will write I just want to bring it in on the same page. Post hoc was conducted using Tukey's test, and it shows a significant difference between fourth year and first year. Between fourth year and first year. What was the value of fourth year? That is 4.6. What was the difference? That is 4.6. Mean difference. And fourth year and second year. Mean difference 5.2. So we accept the null hypothesis. So we reject, yeah, we have to reject it. Reject the null hypothesis that education levels have no effect on pain scores. Okay, so this was about the ANOVA test. Once again, and let me show you guys. what we did, we just ran the ANOVA test and I chose the post hoc test. Okay. And I just copied this table from here to the Word document. Okay. And then I checked which values are significant. Okay. These values were less than 0.05. I just highlighted them as yellow. Those values that were significant and they had negative values, we will not be reporting them. We will report only those ones that are significant and having positive values of mean difference. Okay. So we just wrote this line that post hoc test was conducted and show the significant difference values. Now, even if you don't make this table, you are totally fine. You have reported all the data in paragraph form. Okay. And also, even if you copy these tables, these ones, this one and this one, and you ask ChatGPT or Gemini, explain or help me write this test results of ANOVA, it will automatically interpret this for you. Okay. So even if you are facing difficulty in running and understanding and interpreting this table of ANOVA test, you can just use any of the software. Okay. One thing I wanted you guys to know, whenever we are doing analysis, we have this thing in mind that it is all about running the different tests, but it's not like that. If you will see articles that are published in high impact factor journals, like let me show you guys, that is severity of anemia. I guess it was this one. Yes, I guess no, it's this is not the one. Okay. Severity of anemia, a cross-sectional study. Let me show you guys how they have written their results. Yes, this one. Okay. Let me show you guys the result section. Open up the full PDF. Okay, so let me just copy the results and just let us analyze the results for the time for the last. It's the last thing that I will be doing. Okay, then you guys can be free. Okay, just let us analyze it here. This article is published in a very good journal, okay, Journal of Health Sciences and Rehabilitation, and I guess it's a PubMed Index journal. And you guys can see here that for the full paragraph, even in like two-thirds of the results, there are no tests conducted. It is just describing of the data, and they have done it in such a nice way that the article is being considered. It is published in a good journal. Okay, so we always undermine this step of just describing your data. Okay, so what have they written is they have written that the table one illustrates the gender-wise distribution. There were these many males, how many females were there, how many were having anemia. They're just describing the result. There is no test done. Okay. Once again, next in table two, they are saying that this was the years of MBBS and this was the levels of anemia. Nothing more, no test done, just describing of the results. Next one, we move on. Again, there were people who were skipping breakfast and they were anemic and some were not anemic. And once again, just describing of the results, no test done. And the last one, I guess they have suggested that there was a correlation test done and it showed a correlation in it. Okay. So you can say around 80% of the results are about how you describe the results, and 20% are about applying any test. But we limit the test results to only the analysis part. Okay. I have seen many of my students, even when they are writing the results, they skip out on this thing that how to beautifully write and describe the data. Okay, so just we will go through that step because I have shown you guys the difficult part first, and but I just wanted to let you guys see how to just describe the results in a nice way. You will just go here in analyze, descriptive statistics, descriptives, sorry, analyze, descriptive statistics, frequencies, and you will add all of them. here, and you have written the display the frequency tables. Okay. These tables, okay, they are important ones. You have to, for the first categorical variables, you have to explain their stats. This one, back pain. I will copy it. I will paste it here. I will copy this one and this one, and I will paste it here. Some of you guys, what you do is when you are writing the results, you paste the tables as this. Have you ever seen in any article that is published tables made like this? No. Okay, so you have to do is you have to make proper tables. You can use this one, you can use the tables here, give a proper heading. And you guys cannot understand that these things are so important when an article is being considered for publication. I have seen many people say that cross-section studies do not get published, but the only problem is that we do not give importance to these things. That's why cross-section studies face problems. Okay, otherwise, most of the journals, whenever their issue is released, you can see around 5 to 6 studies are cross-sectional, one meta-analysis, one case report. Like the major portion is the cross-sectional studies. So it's not the problem with the cross-sectional studies, it's just about how you guys are doing the cross-sectional studies that's facing the problems. So the table one, that is for the demographics, always demographic variables. You will write here gender, you will write here variable, then gender, in front of it male, female, frequencies, percentages. Okay, and now I will not be making separate table for the demographics. Next one, I will include year of study. Then I will write here first year, second year. I will write the frequencies and the percentages in the front. And then for the back pain, same as that. For the quantitative variables, what I need to do is I have to go into the descriptives, pain, weight, weight. I have to report their mean, maximum value, and standard deviation. Okay, I have to report them all. This table I have to report that the mean pain score was this one, this was the minimum value, this is the maximum value, and the standard deviation. So this is known as how to describe your data. Okay, so another tip is always whenever you are doing a cross-sectional study, just open up your parent article. Okay, the article that you are trying to the article that resembles your research, and just see how they have reported their results, how they have made the tables, how they have reported the result. That will automatically increase your chances of publication to around 80%. Okay, because you are copying or trying to copy a table that is results of a research that is published in a PubMed index journal. Okay, so these are some of like the tips that you can use, and you are good to go with the results portion. So that was it, I guess. Yes, that was all from my side. If you have any questions, you can let me know. And I will be sharing with you guys this data set and also the link to download SPSS. And one more thing, that was these slides. Okay. And even I will share with you guys the recording to do correlation regression. You guys can practice it on your own. But that's a really important skill that you guys should know how to run analysis on SPSS. Okay. That's like the basic thing of being a researcher. Thank you so much.
Thank you, Dr. Sumya. It was very informative session,
You are welcome. Thank
and
you so much.
hope you guys have enjoyed it. See you next time, inshallah.